Hey everybody, how are we doing? Good to see you here. Tiffany, good to see you here. Carly, got two questions to start off. Visualization number 7 and Carly's question on the twin question on the homework. Let's go check these out. So we have right here kind of our guideline for what we should be talking about. I think a lot of people sometimes with this purple portion here is where the errors occur usually on interpretations for confidence intervals. So the two confidence intervals we're covering with this assignment right now are confidence intervals. Vincent, good to see you here. Drop some questions in the chat if you have them. I think Mewbot's awake. I think he is. Let's re-wake up Mewbot. Mewbot, wake back up. Okay, Mewbot's waking back up. Bring our world back, Mewbot. Ooh, that was a long time. Sherry, good to see you here. Drop some questions in the chat if you got them. With this interval right here, we have to look at our level of confidence. We are 99% confident. That's the interval we're building. And Mary, good to see you too. Mary Beth. And so the problem usually becomes when people go to the purple portion right here, which is we're talking about the true proportion of people who are in Greek life. Just imagine you're talking to someone. Kayla, good to see you here. And you'd say to someone like, I am 99.9% confident the true proportion is contained in the interval blank to blank. Well, what are we talking about right here? I am 99% confident the true proportion of students who are in Greek life. So this is where the mistakes usually happen on interpretation. Just pretend someone's reading what you wrote. And if they were to read, I am 99.9% confident, and you only have here the true proportion, if you just write here like true proportion, we're lost our stuff right there. If you write true proportion, well, that's not enough information. You got to spell it properly too, right? So if you write the true proportion and then you don't give any other info, well, it doesn't quite make sense. What we have to do is we have to say, I am blank percent confident that the true blank, and then we have to give what we're talking about is contained in the interval blank to blank. I broke it. I have no idea what's happening with it. Oh my gosh, everything went crazy. I put that in my Word document, but I said I did something wrong on the 3. And so when we get to the 3 conditions right here, our 3 conditions are going to be, if it's categorical, this Word document is going crazy. If it's categorical, we have our starting conditions of random. Was it randomly sampled? 10%. We use the same format exactly because that one was for the proportion. The other ones could be for the mean. Same format, but just make sure it's not true proportion anymore. It's true mean of whatever you're talking about. So when we do our conditions right here, the 3 conditions, the first one's usually easy, random. Was it randomly selected? And make sure to explain to somebody these were randomly selected because of the conditions here. The 10% condition, well, for this, we always do what? So when you explain the 10% condition, what would you explain? Make sure to give sample size, give population size, or estimate of it, then tell someone if this is more or less than 10% of the population. So going through this right here, Ditto, good to see you too. When we do the 10% condition, we give our sample size. Then we give the population size or we get an estimate of it. Like if I say I sample 200 people who are U.S. citizens, would you say we pass or fail the 10% condition? I sampled 200 U.S. citizens. I didn't give you the population size, but go out on a limb right here. I sample 200 U.S. citizens. So would you say, Brian, you pass the 10% condition or you fail it? So this is where we might not give you a population size and you just have to go out on a limb and be like, I'll bet you... like you could, how would you explain that to me? Well, we got to go off. I think I had top chat on the whole class. Why does YouTube make top chat a thing? I just want to see chat while it happens. Who doesn't? So I talked to 200 U.S. citizens. Would we pass it? And then I would say, so Kale, that is true right there. You're 100% right. I'd say like something, there's like 300 million people in the U.S. This is definitely less than 10%. We totally pass it. Never hurts to throw in a little extra, little Salt Bay extra in there. We need like a meme of Salt Bay in the corner whenever we do a little extra. So we definitely pass it. It's definitely less than 10%. So now, the last one right here, boom, right there. 200 is definitely less than 10% of the U.S. population, so we definitely pass it. The last one right here is success failure condition. Maybe we were asking them, and it has to be categorical for this, we're asking them, do you own a dog? And in our sample, let's say 80 of them own a dog. And 120 don't own a dog. Because you either don't own a dog. You either own a dog or don't own a dog. And this is NP hat, NQ hat. Make sure you look at your numbers, double check your numbers, and give your numbers. Give your numbers. So if you notice what I'm doing right here is I'm giving the numbers that 80 of them own a dog and 120 of them don't own a dog. Now, do I pass or fail this condition here? Just put pass or fail. Remember, the success failure condition is we need at least 10 successes, at least 10 failures. So the success failure condition here would be checked with NP hat and Q hat. And so we can actually check it up here. So this is NP hat right here. You could check the numbers. Your X, excuse me, this is NP hat right here. It'd be found by doing 0. You don't have to do it because it's already on the screen, but it could be found this way. And other than decimal place accuracy, it is 89. So on both this right here, we pass because 89 is more than 10 and 159 is more than 10. And this is P hat and that's Q hat, respectively, right there. So that's P hat, the sample proportion, and that's Q hat. So great stuff right there. And NP hat, NP hat is equal to X. So this would pass also right here. This would pass because we have at least 10 people owning a dog and at least 10 people not owning a dog. Now we get down to quantitative, the rules change for the third condition. And so when you do the third condition for quantitative, some people might be a little bit worried because there are outliers here. If you notice right here, it's being totally weird. If you notice right here, there are some outliers. But how could you explain this right here when looking at a quantitative distribution on whether or not you pass the nearly normal condition? Way number one is to look at the histogram. Looks mostly unimodal and symmetric. That's good. But I mean, there is some outliers. More on that in a moment. Way number two is to do a normal quantile plot. We have those in the notes if you want to check those out. Normal quantile plot, if it follows a straight line, normal. If it doesn't, good question. We'll do that here next, Tiffany. You got it. We'll go back to reviewing this. And then way number three is to do the goodness of fit test. But then way number four is to do the what. And do I have those notes up? Way number four is to do the what to check it. What is the fourth way to check it? The fourth way to check this right here is to do what? What is the fourth way to check it? The fourth way to check it is to do what? Trying to find where we wrote it down. The fourth way to check it, I think I did it more in the other set of the notes I have open. The fourth way to check it is to do what? The fourth way to check it. So many notes. The fourth way to check it is to do what? Oh, where'd my beautiful notes go? Look at the sample size, which we have right here. I'm just trying to find the nearly normal condition. So we have way number one, make a histogram. Way number two, look at normal probability plot. Way number three, look at the goodness of fit test. And then way number four is to look at the sample size and see if the sample size is large enough. So here's where people usually don't give enough information. If you look at this right here, what should you look at first? The first thing you should look at is the what of the distribution. When you look at this right here, you would need to communicate to someone first the what. So you should, when you look at the distribution, communicate to someone first the what of it. If you're doing the large enough way of passing the nearly normal, you need to first look at that and communicate to them the what. The first thing you'd have to do is communicate the what for it. So you look at it and you say, that looks like a normal. Great job, communicate the shape. So when we get to the nearly normal right here, passing via large enough, which you can do, hint, 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 we would look at first communicate the shape of the distribution. Next, communicate the size required to pass for this shape. Finally, communicate whether you have this sample size or not. So let's look at mine. Mine right here looks mostly unimodal, mostly symmetric, maybe some skew, maybe some light skew. So if we go back here and we take a look at the notes, it says, if it is unimodal and reasonably symmetric, I need a sample size between 15 to 40. So I could say that. I could say mine is mostly unimodal, reasonably symmetric. So I need a sample size at least of 15 to 40. At least 15 to 40. I wish it gave more exact numbers. That's why I like my 125, 100 better. But we need a sample size of at least 15 to 40. Do we pass right here? So once again, my distribution is maybe a little bit skewed. I need at least 15 to 40. So follow right here. Way number one, look at the shape. The shape is mostly symmetric. Then we look at our guidelines right here. So when we look at the guidelines right here, I'm in this category. So I need a moderate sample size of at least 15 to 40. I communicate, here's what we're communicating. My shape is moderately, little bit skewed maybe. It's a little tiny bit skewed. So I need at least 15 to 40. So with a sample size of at least 15 to 40, do I meet that requirement right here? Yes or no? Would I meet the requirement of having a sample size of at least 15 to 40? So these are steps we need to practice. The most important thing is writing down the steps. That's why we write down the steps, and then you got to practice. So we write down the steps, and we're like, okay, I look at it, and it looks a little bit skewed. I need at least 15 to 40, and then I have a sample size of 248, so I pass. This is what you need to communicate to someone. This is what you need to communicate. First, communicate the shape. My distribution looked a little bit skewed. Like there was some issues and some outliers that looked a little bit skewed. Next, communicate the size. Because it's a little bit skewed, I needed a sample size of at least 15 to 40 to pass this condition. Do I have this? Yes, I do. My sample size of 248 is large enough that we pass the nearly normal condition. So follow these steps right here if you want to pass it by way of the large enough. Make sure to make it very clear as you walk through and explain to somebody, here's the shape of my distribution, here's what's required of that shape, and then is it normal for me to have it sounds like you might not have taken your subset. The very start of this question has us taking a subset of 200. Make sure, I should have noticed that. You should have a sample size of 200 something for these questions, I believe. I think we did that too. We have a sample size of 200 something. So for these questions, double check. Make sure you have a random sample of 200 something. And when we're interpreting these intervals, so the confidence interval interpretations, I don't know why this is acting so weird with the highlights, where I lost my highlights. But when we interpret these intervals, what were we trying to estimate right here? The true what of students. So for my interval, and we just plug in the numbers for where they're at, but usually the pink areas where people get really confused, we're trying to estimate the true what of students. Now it's quantitative, so the second one might not have been taken via the random sampling. You might have to regenerate it. The second one sounds like it was taken from the full data set. Make sure to do it from the high school GPA. Great job, Mary Beth, right there. And the true four-letter word for the high school GPA of students. I am 92% confident the true... And then we're trying to estimate the true what. The true what for 100 points in the title. Throw us more points. The true mean GPA of high school students. So the true mean high school GPA. Does that make sense right here? So if you notice it has mean next to here, which is a good indication. Does the other one say proportion too? It doesn't say proportion right here, but it's got like prob right there. I wish it said proportion. This one's a little bit more clear. It says mean right here. So you're trying to estimate the true mean high school GPA of students. Like, what is the true average GPA of students? And we're trying to estimate that right there. This is being so weird. No idea what's going on. Does this make more sense to everybody right here? Good practice on this. I think we're going to do the next question right here. But make sure, this is good skeleton work right here to make sure to put in. But practice doing this. I am blank % confident the true blank is contained in the interval blank to blank. A lot of my Pearson questions are going to follow that format. They might say we are, one can be. It's all the same thing to say like I am. How to get the graph? Double check the video. I'm gonna continue on, Tiffany. Double check the video. Let me drop the visualization links in here. So the visualization playlist. So let me drop in the visualization playlist. Confidence intervals for the means. So this walks through, check out these right here. And so Viz playlist, check out this right here. This has walking through each one right there step by step and also explains it in another way. So you get to hear a few different ways of explaining it and walks through each one with each button click on how to get them. Great questions, everybody. Amazing work. We'll head back here to the main screen. We'll put interpretations for visualizations right here. Good stuff. Oh my gosh. I'm pressing all the wrong buttons. I fear if I did that part last, it would be like, what officers? I think we did it last one, right? I think we did it last one right there. I think we did it Check out good questions right there. And then also the Viz playlist has all the good stuff right there. And so if you click on the visualization playlist, it has a walkthrough step-by-step button click for each one. Good stuff right there. Let's hop into the next question. Got a lot. Could you do the twin question? Let's do the twin question. So Carly's question is the twin question. The twin question getting loaded up right here. And thank you, everybody. Whew. We're into the tougher statistical material. We only have a few more homework assignments left. Here we go with the twin question. Awesome. Thank you so much. I'm a twin, Carly. That's awesome. Are you identical? If you want to say in the chat, 100 points right there, everybody. Let's hop over. We just watched some Twins Fear Factor right here. We didn't watch Fear Factor tonight. Fear Factor is such a good show. Crazy show. Crazy show. Well, let's go check out the twin question. Here we go. In 1998, forever ago, a national vital statistics report indicated that 2.9% of all births produce twins. Is this twin rates the same? They are fraternal? Ah. Yes, and my brother... Wait, your brothers are twins too? What? It's crazy. So... That's so crazy. I've always wanted to have like an identical twin. That'd be crazy. This thing's getting crazy. Number fourth. Oh, Kayla, you're awesome. Data from a large city hospital found only 10 sets of twins. So I'm going to circle the notation here. Help me out with the notation. So this is what we previously believe. This is what we see in a sample out of 512. Help me find some notation. Who's got notation right here for this problem? Find some notation. I'll find the rest. This is good practice. Whenever you get to a problem like a test problem, if you look at it, you usually want to look at the numbers and be like, what of this is notation? What of this do I need? Do we meet the conditions? Randomly selected, less than 10% of the population, like these 512 sample size, less than 10% of the population. The last condition is NP naught and Q naught. So if you're watching closely, you'll see some tips on what the notation is, NP naught. And then in Q naught, so you're seeing notation right here as I check conditions. NP naught and NQ naught are both greater than 10. So did you catch any of the notation right there? So the condition, the third condition is NP naught and NQ naught both greater than 10. Who caught some notation right there? We do meet the conditions. Who caught any of that notation for this problem? Any notation? Get me started here on the notation and then we will finish it off. 512 is the easy one. Usually people go for 512. We took a sample size of 512. One of the big keys to this problem is always knowing the notation. From there, the rest of the problem flows. We find the notation and we're like, okay, now I just got to solve some equations. Who knows? 100 points in the chat. And right there, Sherry's starting us off. We like it right there. I'll get another one going right here. Yes, basically. Mary Beth, you are correct. That is we'll be using that here in a second. So we need to identify those things. So Sherry, Mary Beth, great job right there. This is X, because that's the number of successes in the sample. And this is P naught is equal to this. This is P naught because it's what we hypothesized to be true. And Q naught is 1 minus. And I can't write things today. I used the wrong number when I did Q naught. Oh, it's great job. I hope I'm not buffering anymore. We haven't had bad buffers lately. No buffers, no buffers. So P naught is 2.9 or 0.029. Does that make sense? So that is P naught and then Q naught because this is what we currently believe. Does that make sense? Thank you so much, Mary Beth and everybody. Helping out with pressing live right there. I'm glad it fixes issues. We're generally pretty good on YouTube. What does the null always have? The null always has the equal sign. But now we have to solve. Remember, we practiced today. If you were in class earlier today, the null has the equal sign. Is this rate of twin birth the same among young mothers? So what would be the appropriate alternative? We're testing the null hypothesis that the twin birth rate among young mothers is equal to 2.9%. And then the alternative would be that it's not equal. Carly, great job right there, Carly. Because They're asking, is it the same? So that'd be where we notice right here in the question. The question would dictate it's either the same or it's not the same. Does that make sense? It's either the same or it's not the same. And so we're looking for evidence of a difference. So that's a little tricky right there, a little tricky. And good stuff right there. And so now we have to find the z-statistic. To find the z-statistic, we'll write the equation right here. We are given these equations on the test. Great job, Kayla, also. We have here, so p hat minus p naught. This is given on the test. And then I think Mary was saying this is the standard deviation of p naught, I believe it's notation-wise. I don't usually call it by its notation form. But it's still just a standard deviation, a standardizing factor. Why is it a standard deviation, not a standard error? Because it's assumed to be true. So we don't call it a standard error because it's based on the null hypothesis, assuming that p naught is the truth. So we call it a standard deviation. So it's a standard deviation of, I think of p naught. I could double check the notes. We won't quiz you on what is it called in the chat or on the test. So now we take the numbers we found. Oh, we didn't get p hat. Find p hat for me. Here, we'll put that up there. Find p hat for me. Meant to hit the eraser. Who has p hat as Brian rewrites all his notation? What is p hat? You got it, Kayla. So you got it. Go ahead and solve it. You got it. You got it. Good practice. P hat is x over n. Just solving it out here. Nice. Thank you, Kayla. Great work. Smallest possible handwriting. Watch me erase it again. I'll just scream. Like, no! Eraser. Not massive erase. Might actually have an undo button. I should have looked. I don't see an undo button, though. Great job. Thank you, everyone, carrying through the decimals right there. Marybeth, great job, too. And so we're just going to solve this out right here. This will get us the z-statistic. So let's solve for the z-statistic right here. Ah! Kayla's with 100 points. Kayla's like, if you want the decimals, I think we're good on the what you gave. And remember the Q naught is 1 minus P naught. Good, good, good. We're going to copy that. That's the bottom of the equation right there. And the z-score is that. Ooh, I can guess the p-value. So the z-score is negative 1.27. 1.277. Negative 1.277. That's good enough rounding on it. So interestingly enough, this is a z-score basically close to one I know. So negative, really, 2 decimals, negative 1.27. Check answer. What did we do? Oh my gosh, you got to be kidding me. Do you see it? That's what I say to the next question. So let me explain how I was able to get the next question and why knowing the empirical rule is important. So we have here the z-score. Make sure to round it to the proper decimal places. My person's going to get a little bit angry if you don't round it properly. Please tell me if you make a small error like that. There's somewhere you need to be very decimal place accurate. If you said, hey, Brian, I took off 1 decimal like you did, made an error. You guys know I give some points back. But there are some especially with t intervals where there's going to be small differences if you use a t versus a z. So be very careful. That's where you might use the wrong calculator and the differences are going to be more interesting. So what I know, and we'll draw this out here in a second for people to see, is if you go to the David M. Lane and you draw out the normal curve, you would get the following picture. Now, we are doing a what test? What is our alternative? Can anyone remind me, what kind of alternative are we doing? So what kind of alternative are we doing right here? And why is that important? We landed on this curve, and let's put the p-value or the z-score in right here. We landed over here. So we landed at a z equal to negative 1.28. So what alternative are we doing, though? So why do we need to know the alternative, and which alternative are we doing? Why is the alternative so important for what I'm about to do with this curve right here? Since we're using the does not equals alternative, which is what we're using, when we shade, the does not equals tells us that we have to shade what sides of this curve. By using the does not equals, this tells us what? What does the does not equals tell us when we are going to shade the curve? What is the does not equals going to tell us we have to do? Since we're using the does not equals, it is telling us we must do what? The does not equals, what is it going to tell us we have to do? So let's think of the does not equals like this. So what is the does not equals going to tell us, which is so important? There's like a key concept to know. If you have a does not equals alternative, it'll be a what tail test. And so I think, Kayla, you're on the right track right here. When we have the does not equals alternative, we are then going to shade the opposite side of the curve in just the same area. And so let's say I told you, and that's a z-score just as extreme. If I told you that this area here was 10% of the curve, then what does the does not equals p-value equal up to? If that area right there is 10% of the curve, then the does not equals, yeah. No, well, Kevin asked the question now. We've I think got a few more 201s, but Kevin, go ahead and ask. This is for 320 also, so go ahead and ask any question you have. Feel free to be like, hey, can you talk about this for indicators and that kind of stuff? You got it. Just jump in, ask questions, you got it. So what does the full p-value going to be right here? If that's 10% on that side, the other side is 10% too. Exactly. It's the same exact area on the curve. And so if you're wondering how I knew the answer to the next question, it's because on the David M. Lane, which we don't currently have up. Oh, no worries. You can drop in the chat and I'll try to get to it. So let's show what this looks like. David M. Lane's going to jump up on the screen right here. So remember, we have a z-score of negative 1.28. Might have accepted 20%. David M. Lane, Ubot, it's going to bring it up. Here we go. So we have to shade both sides of the curve, remember. Both sides of the curve are going to be shaded. Where's that camera green? I feel like I'm a little small here in the corner. There we go. That looks better. And so we are going to go outside of negative 2.8. And then on the positive side, we also go to it. And there it is right there. And it did round. We got it to the decimal place accuracy today. And the reason I know this is because I know the z-score for the following. Oh, maybe I don't today. But I know an 80% confident z-score. And so when it was 1.28 or negative 1.28, I kind of knew the answer because I know this one by memory, the negative 1.28, and then the remaining decimals I don't know so well. But with this right here, you will put in your z-score, and you will get your p-value here depending on if it's a greater than alternative, a less than alternative, or a two-sided alternative. If you had done the greater than alternative with this, you'd have the following: a less than alternative. Kayla, you're the best. Kayla, you're just, thank you so much. And so the less than alternative, what do you notice about the greater than and the less than alternative? Like, they add up to what? Which we mentioned in class today. The greater than and the less than alternative add up to what? Like, if you do a less than alternative, or you were to look at a greater than alternative, they add up to what? The greater than and the less than alternative add up to what? If you were to look at both of these, you would say, well, that's just blank percent of the curve. Here's the less than alternative. Here's the greater than alternative. And you're just going to wherever you landed and shading either above it or below it. The greater than and the less than alternative add up to this, which we do test questions like this. They add up to 1 or 100%. Mary Beth, amazing work. And then the two-sided alternative is what, just look at it visually, the two-sided alternative is what to the smaller of the two. If you look at your alternatives, less than, greater than, the two-sided will always be what to the smaller of the two. So it could be any value, but the two-sided will always be what to the smaller of the two. You can just see it visually, and you can see it mathematically down here, where this is 10%, and then this here is 20%, rounded. Awesome. You're welcome, Kevin. Yeah, swing by and just drop those questions. You got it, Kevin. And so the two-sided will be what to the smaller of the two. Here's the smaller of the two. Here's the two-sided. So, but when you look at this right here, here's the smaller of the two, and then look at 10%, and then look at this visually, and now it becomes 20%. So the two-sided will always be what to the smaller of the two, because you're just going to reflect it on the other side. So the two-sided will be what of the two alternatives, of the smaller of the two. The two-sided you take the smaller one and double it. You got it, Mary Beth, another 100 points in the chat. So that's how we can solve it, and I'm doing a lot of those calculations for myself when I'm doing this. Like, I'm kind of solving because I know some z-scores and stuff. What is your conclusion? We either reject the null. Hassan, good to see you here. We either reject the null or fail to reject the null. And if we fail to reject the null, it's because the p-value was higher than alpha. And that's what we're going to do right here. P-value is 0.05 or alpha is 0.05 unless otherwise stated. We fail to reject the null. The proportion of twins for teenage mothers is not different. So that's what we assumed. We assumed it was equal to what we've seen, and we do not reject that because the p-value is high, and just let that null fly. And then, Tiffany, just go ahead and remove that. That does sound good right there. I'm going to remove... Here, I'll remove it. No, don't worry. Tiffany, I just removed that since it is an answer to the question. That does sound good, though. That does sound good. That does sound good right there. That does sound good. You're welcome, Carly. What question do we have next? Tiffany, great work right there. That does sound good. That does sound good. Let's hear it here. I think we had another one. Let's go to the main screen. Great work, everybody. I think we have a few more. I know I saw another question. Next question wasn't there another one? Am I going crazy? I know there was another question, was there not? What questions do you have? We still got a lot of time left. I think we go for another 45 minutes. Let me clear this out. Got a random text message. I don't think that one's spam. We could do another testing question. Drop those questions in the chat that you have right now. I thought I saw another question. What questions do you have? Let me get the quiz loaded up because we've done a lot of the homework. The radiation fallout question, you bet. Ivy, good to see you here. Of course. Let's go check the radiation fallout question. That sounds exciting, right? Sarcasm implied. Radiation fallout question. Let's go work on it. Here we go. Gotta go find it real quick. Philanthropy, vital statistics, nonprofit, airline, startup company. Radioactive fallout. Exciting times here on Stat 1. Let's go check out. And then an organization monitors. You bet. Got that one next. Let's check it out. Okay. So we're dealing with proportions right here because radioactive fallout is drifting across a region after a bomb. This is awesome. Fun stuff. There were died of cancer. Cancer experts estimate that one would expect 26 to die. So when we say one would expect... yeah, this is where it's tricky. So if it says one would expect 26 to die, according to the experts, what does that sound to you like this one would expect? So if you would expect 26 to die, that's amazingly fun stuff. If you'd expect 26 to die, then that sounds a lot like the what right there. Trying to change the dot size. Oh, there we go. If you'd expect 26 to die, that sounds like something we would associate with the what. If I say I expect 26 to die out of the 210, so this one's very interesting how you have to find this because not quite, 26 is not, very close, Sherry, very close. 26 is how many, it's almost like x naught, which I don't really know a good notation for this. It's like what you would hypothesize the amount of successes to be. Does that make sense? I know we haven't seen that notation, but it's like how many the hypothesized amount of successes. I highly doubt you'll see something like that on the test. But what would you use this for then? We would take x naught over n to get what? What do you think right here we'd get? X naught over n should equal what? And I'll solve it in my head. I believe that's 0.1238. I believe that this is 0.1238. If you take how many successes you hypothesize to be true, then you should get what? Because I believe this is equal to 0.1238. So I doubt you'll ever see this notation again. It's for this problem only. Yeah, Kayla, you got it. Because it's but the hypothesized proportion. And this would be equal to 26 over 210. And that is equal to, how did I do that? You'll notice down there on the bottom that you have these numbers here. And so is the death rate observed in this group unusually high? If we're testing to see if it's unusually high, then this sounds a lot like we're looking at the what. We want to see if it's unusually high. So that sounds like that might be associated with the null or the alternative. We're asking, is this unusually high? Is the proportion, this is how we go. I love it. If we're seeing if it's unusually high, that sounds like it might be associated with the what. If we're saying, is it unusually high? So that sounds like it might be telling us about the alternative. And that's going to tell us the sign for the alternative right there. Is this unusually high is the question, what we saw in the sample. And we'll be looking at that sample here in a moment. So going down here, the alternative's got to have the greater than sign to ask, and we do meet the null. We can look at some conditions if we want. Well, there you go. The hypothesized is 26, so that's more than 10. Are these random people? This problem, and is it less than 10%? I'm worried about the conditions, but it's going to say we passed them. I might call my Pearson on this one and be like, hey, I don't know about those conditions on this one. So now it wants the Z statistic. Oh, good. We still have everything on the screen. The Z statistic is going to be Really? The Z statistic is going to be... Perfect. There we go. And let's go to pen. It's going to be P... P hat minus P naught over P naught Q naught over N square root. And so now that we have, let's put in our numbers. The only thing we're missing right here is P hat. Find P hat for me. Practice, practice, practice. Find P hat. So try to do that right now. Here, I'll give you a hint. Find P hat for me while I solve this. I'm going to put in the numbers and find for me P hat. What is P hat going to be? Oh, and then we need Q hat. Q naught. Q naught is 1 minus. So Q naught, I'll solve Q naught real quick. That's P naught. We put our notation in blue here, is 0.8762, I believe. That's 1 minus. These add up to 1. Double check your work right here. Make sure they add up to 1. And so what is P hat going to be, though? We don't know what P hat is right now. Great job, Kayla, right there. So Kayla did X over N right there. Here, we'll put it up here at the top. X over N is equal to P hat. So 41 over the 210 is equal to 0.1952. And so let's go ahead and take that P hat down here. And then we need to do P naught times Q naught over N, which is 210. And then let's solve here for the Z-score. Great job, Sherry and Kayla. Excellent work. Double check your work. That is the sample proportion right there. And now we just need to solve for the Z-score. So the Z-score right here is going to be, I always solve the bottom of this. P naught times Q naught over N square root. There you go. Ooh, that's interesting. Is that a large or small z-score? Is that like it's a little tiny z-score, or is that like, oh, it's a big z-score? What are your thoughts on this z-score, large or small? What are your thoughts on this z-score, large or small? 3.14. Almost pi, 3.14159. Yeah, the notations were the big practices. So that's 3.4. Wait, p-value round. So 3.14. Ooh, I bet we could get the p-value. It's a very, very large. Great job right there. That's a big z-score. So here, I'd like for you, along with me right here, to estimate. We got a lot going on. Since we know, let's clear the screen. We know the z-score right now. I'd like for you, we're going to take a guess, and we're going to show it in the David M. Lane. I like to always take guesses at these because it helps with the understanding of what are we doing. Now, remind me, we had the null hypothesis that the true proportion was equal to 0.1238. We have the alternative right here that the true proportion is greater than 1.238. Will I shade to the right of this, to the left of this, or will I shade like both sides? What will I do? Will I shade to the right, to the left, or both sides of that? So here I landed at my z-score. The z-score is equal to 3.14, 14159. Will I shade to the right of it, to the left of it, or both sides? What do you think I will do? To the right, to the left, or to both sides? Which way will I shade? To the right, to the left, or both sides of it? To the right, to the left, or will I shade both sides? Who knows? Which way will I shade this curve? Now that I have the z-score, and I shade to the right because it points to the right. This points to the right. On the alternative, the alternative tells you which way to shade, and we're shade to the right. Now, using the empirical rule, I know that above here, if you remember your 99.7, that between here and here is 0.997. We can do the David M. Lane in a moment. But this area right here has to be less than half of it. So the area right here has to be smaller than the following. Does that make sense? Like from here over at 3 would be that much according to the empirical rule. So I bet you we could get this right as a p-value by entering 0.0010. And this is using the empirical rule to solve it right here. And I'm thinking we could get it because this would be evidence. Let's double check our work right here. We're going to go over to the David M. Lane applet, and I'm betting we would get it right if we just let it solve with that, but we're going to make sure we get it right by going above and going to 3.1415, and that rounds 0.0008. Or maybe let me do it to this. This is what I'm getting right here, Sherry. The p-value is very, very tiny. That's what you should, if your z-score is different than mine, you will get different values though. If you have that value, your z-score must be about 1 point something. If you're doing a greater than test, it's probably about 1.4 or something. If you're doing a greater than test, greater than, less than, not equal to test, everything's going to change the way the p-value looks. But my p-value is 0.00008. It probably would give me this. We'll check out to see if it would have given me it. I'm off by 2 10,000ths. Mine is 1.05, and then are you doing a greater than test? If your z-score is 1.05 and you're doing a greater than test, that's your p-value. If you're doing an outside test, like it does not equals, it would just be double that. So just make sure you pick the right, like if you're doing a does not equals, it's that. If you're doing a greater than test, it's this, which is half of it, like 15% and 30%. Don't put 15 or 30, but yours is greater than, then you'd be getting 0.1469. Does that make sense? So you just go greater than the z-score of the following, which is close to about 16%. So remember, 16% is basically when it's that, but you're further over, so you've got a little bit less than 16. So empirical rules still apply to this. Is this unusually high? Yeah, that p-value is very, very small. The p-value is low enough to conclude that the death rate is unusually high. This is literally the saying right here, I reject the null hypothesis. This is a very unusual result, so we have evidence for the alternative that this is higher than what we would have expected. Does this prove? It's ridiculous to say this, but whether or not the death rate by cancer is unusually high, the cause cannot be determined. So we cannot say this. We cannot say anything is proven. We should get everything right. Oh, I blinked and I thought I got something wrong. I wonder if it would have given it to us. Oh, wow. Really? Our guess would have missed it. We would have been off by the tiniest bit of amount. We've been off by a 10,000th. It would not have given it to us. That is the right answer here. Make sure to check. Put yours into the applet. Once again, always do a little drawing to help yourself out, and then put it into the applet to find out with your z-score what is the exact p-value. Great question. Really good work right here. What we've covered today in class, if you are in the afternoon class, you're going to see these step-by-step, writing out the null, writing out the alternative, doing the mechanics of the test, finding the z-score, finding the p-value. This question in and of itself is the majority of the chapter. Great job, Sherry. Great work. I think there was a second one here. I'll top to the main screen. So next question. Okay, so the next question was an organization monitor on the homework question. An organization monitors on the homework. An organization monitors. It's so weird. You get that fallback hour, and everyone's like, I don't know. I was like, I don't need to go to bed. I got an extra hour of sleep. It was really nice. Saturday to Sunday. Really good. Just able to relax and get that extra hour. But then you get spring forward where you lose an hour, and it's like, oh my gosh. I have lost an hour, and now I'm half awake. Should just try to get an extra hour of sleep during the week, right? Be good. And organization monitors. Let's go check out an organization monitors. Here we go. Let's do it. So an organization monitors the kind of school attendance of students. We have back in 2000, the perfect attendance rate was 38%. And then it's dropped in 2004 to 37%. There were 8,806 students sampled. Now here's the biggest thing. They would be interested in a decline, but I think they wanted to, I remember years ago, this question used to be different. They're looking for evidence of a change. Oh my gosh. They're looking for evidence of a change. So when you hear evidence of something, you're thinking this is associated with the what? So whenever you hear like evidence of something or what they're looking for, this is statements associated with the what. If you hear they're looking for evidence of a change, you'd say, Brian, they're talking about the what right now. They're talking about the notation I will use for the what. So when they're looking for evidence of a change from 38%, exactly. Great job, Kayla, right there. 38% is the hypothesized proportion. That's what we're saying we believe is true currently. And then we would say right here, the alternative, we believe that, well, that's not the null. The null will be that the true proportion is equal to P naught, because that is P naught. And then the alternative is what we look for evidence for. And I think a lot of students usually, don't worry, I've maybe gotten this wrong once, but this part right here, it says, is there evidence of a change? Got 100 on a quiz, 100 points right there, Sherry. Great work. Quiz done for the week, or for this one. And you've only got like 3 more quizzes, Sherry. 3 more quizzes, like a month to go of classes, 3 more quizzes, like till the final. Whew, nice job right there. 1 more quiz down, keep knocking out those hundreds, then you're done. Great job. Are the assumptions met? Independence is basically... I want to listen to the whole song. Don't want to get copyright claimed. Is plausible. Is this less than 10%? Is plausible. And this is met because NP naught and NQ naught. Logan, good to see you here. Feel free to ask some questions. And these are met. So now we get into the z-score. So how do we find Q naught? In the chat right now, worth 100 points. Nice and easy. Find Q naught while I talk through the other bit of notation. This is once again where if you get the practice, you can find these things pretty quickly. Here's N, which is the sample size. And here's P hat, which is the proportion out of the sample. Let's write our equation right here in pink. So we have P hat minus P naught equals P naught Q naught. 1 minus P naught right there. Can you do the airline question? You bet, Logan, of course. Great job, Sherry, right there, also finding it. And don't worry, someone in class is going to ask, how did you get Q naught? You say 1 minus P naught. How'd you get P hat? 1 minus P hat. Oh, how'd you get Q hat? P hat is X over N. This one just gives you P hat, but going on calculator hunt. Be right back. Love it. The practicing the notation is a lot of key for these, and being able to identify 37% was the percent out of a sample. We have here the null proportion, which was believed to be true. And then we have right here, we take the null proportion times the complement, which is 1 minus the null over the sample size right here. And there we go. And yep. So let's go ahead and solve this. We are just punching in. We do the bottom portion first. And we square root. And it looks like we're going to get a z-score about 1.91, maybe. Ooh, that's a little more tricky of a one to solve. Negative 1.85, and I should have said negative. This is because it's declined. Now, once again, the alternative is not decreasing because they're looking for evidence of a change. So with evidence of a change, we're seeing if it's not equal to what we previously saw. And so we do see it has declined. We're looking to see evidence if it's changed. So this z-score right here, negative 1.85. And this one's a harder one to guess. Ooh, p-value to 3 decimal places. Tricky. I always like taking a guess at this. Who's got a guess? We're going to draw this out. We're going to take our z-score and draw this out right here. I want you to take a guess with me too. I know you might be saying, well, Brian, let's just go to David M. Lane. You are correct. We are going to visit David M. Lane in a moment. But we are seeing if it's changed. We need to know what we're supposed to see right here. So here we are with where we landed. Let's draw where we landed first. We landed right over here. And then one just as extreme is over here. So our z-score was equal to negative 1.85. A z-score just as extreme is a z-score of 1.85. Why are we shading both sides? Because we're doing the does not equals alternative. So now we shade this side and we shade this side of the curve. This is the drawing we will get. Who has a guess right here? We get 2 guesses. I'm going to take my guess. Oh, it's a tough one to guess. It's a tough one. So I know what numbers it has to be between. Oh, it's a tough one. We got it. There you go. It's solved. I knew it had to be a little bit more than 5%. 10% is a z-score of 1.645. So because I know a bunch of numbers on the curve, like 1.645 for a 90% confidence roll, if 90% is inside, then the outside of a 95% confidence roll is 10%. So Kayla, maybe those things will start clicking. Don't worry. This is like the more advanced stuff, because what can we always do? And we'll always give you like pictures for the test. You will never have to do something where you have to straight solve it. But 10% is a good guess, Kayla, right there, 100 points. Like 10% is a close guess. But this is why I like to say to people, the applets are good, but if you understand how the curve works, you can draw your picture and take a decent guess at it. And our z-score here is negative 1.85, and we go to positive 1.85, and there it is right there. I was barely close enough. And so, yep. And so do a drawing of your thing. Yeah. And so, yeah. And just be able to be like, like, don't worry about being too close. But here's the thing, like, draw this out. Every time you get it, draw what you expect to see. And I didn't make the tails right there flat enough. Oh, you doubled it twice. Yeah. And so draw it out, see what you get. And remember, we know that at 1.96 is a 95. You've been doing like 1.96. So you kind of a guess that it's around like more than 5%. So that's how I was able to take a guess at what it was and get close enough that it gave me credit. But once again, you'll use the David M. Lane for the assignments, and tests might have you, like if the test asks you is the p-value, 6%, 20%, or 80%, like you should be able to narrow it down with a picture. So the picture, like even if we didn't give you the value down here on the bottom and you drew this out, if you were asked, is this 6%, 20%, or 80% of the curve, it should be kind of obvious it's close to 2, which is close to 5%. So you should be able to say, well, it has to be closer to 6%. And just visually speaking, if you draw it out. So we might not give you the drawing. We might tell you a z-score, but then you should be able to associate big z-scores have smaller p-values. Z-scores closer to 0 will have the bigger p-values. And this is where just drawing it out is the practice. State your conclusion with an alpha of 0.1. I think we still have the notes up from today. So using an alpha of 0.1, how do we use alpha? It says use an alpha of 0.1. Our p-value, I'm going to draw this out so we can see it from today's. Our alpha is 0.1, and our p-value is p-value of 0.066. So, or 64, because if we do what their numbers were. So what are you going to do right here with an alpha of 0.1? What would you do right here? So alpha is assumed to be 0.05 unless otherwise stated, but they're saying use an alpha of 0.1. That's a very key part to this question because this would be 0.05 unless otherwise stated. So alpha, which is sometimes shown as this, is 0.05 by default. They are not saying that. They're using this. They are not using the default though. Yep, you got it, Kayla. That's just how like I know it gets easier with practice. It's almost like, how'd you do that? All Kayla did right there, and great job, Kayla. Another 100 points. Keep getting those points. It's leaderboard, tight leaderboard. P-value's low, reject the null. P-value's high, just let the null fly. That's the way to memorize it. And the p-value is low, so you reject the null, and that means there is evidence for the alternative that it is changed. Now, why are we saying it's changed? Because that's the alternative up here. We reject the null hypothesis, and we have evidence that the true proportion has changed and is no longer. Wait, careful. You might be in the afternoon class, Mary Beth. We never say the except word. If the p-value is higher than Mary, 100 points right there. No except. We reject or we fail to reject. Kayla's got it right there. Don't worry, we'll practice that. If you see except on the test, it's probably a trick question. So if you see accept the null, probably a trick question. We reject or we fail to reject. Let me ask you this. Today, I will probably fail to go to the mall. What am I saying if I say I fail? No, Mary, don't worry. 100 points. Don't worry. This is why we practice. Like, you got it. Today, you'll be saying it when people say accept, you be in the chat and be like, don't say that. Don't say that. If I tell you I failed to go to the mall today, what would you tell me about Brian going to the mall? Today, I'm going to fail to go to the mall today. So if I say I failed to reject something, so I failed to go to the mall today. Brian did what? I failed to go to the mall today. I failed to go to the mall today. So if you think about, it's a weird way of saying it. Today I failed to go to the mall. Like we fail to reject the null. It's the same thing as saying what? Yep. So you either reject the null or you do not reject the null. Like you either go to the mall or you fail to go to the mall. Does that make sense? Like it's just how old time it's still used. If I could change the way the world talked about these, one at life, I would change it so we never say fail to reject anymore. But because it's so prevalent, we have to teach you it. But so you should know if someone says fail to reject, they're just saying I do not reject. Now that doesn't mean they accept. You either reject or do not reject. Think about it as complements of each other. Like you will either reject or you will not reject. Like one of those two things must occur. And not reject is the same thing as fail to reject. Like, so yeah, and it's just a weird way of saying I didn't do this. Like I don't reject the null, but you don't accept the null. You either reject or don't reject. And you have to hear the wording fail to reject. Oh, thank you, Mop Pearson. Mop Pearson doing some better way of talking about stuff. Fail to reject is just, you'll hear it in disciplines. People say, do you fail to reject the null hypothesis? It just means you don't reject it. Mary Beth, every time I'll try to remember today, it'll be in class to learn a little bit. I'll try to remember and throwing you a bunch of points when you're like, don't say that. I'll say like, what's the bad A word? Hopefully people would accept and not other words in the chat. Do you think this difference is meaningful? We see a difference of about 1% right here. And this goes to the idea of what practical significance is. The difference is probably not meaningful, even though it is statistically significant. It only changed by about 1%. So are we super concerned about attendance dropping or changing, technically due to the question? It's probably not a meaningful, practically significant. My Pearson really trying to do a bunch of, which is a great question, is this difference practically significant? If I tell you there's statistically significant evidence that people on the Discord get a higher score on their grade by 0.05, or let's say 0.02. If you're on the Discord, the difference we see between scores of people on the Discord and not on the Discord is about 0.02 on their final average. And this is statistically significant, not because it's 0.02, but because I ran a test and p-value came back less than 0.05. Now, you might say to me, that is important to me because every little bit matters. Or you might say 0.02, that's so little, it probably wouldn't change anything about my final average on the ABCD scale, F scale. So practical significance is what they're honing in on here. Does the difference matter to you? And this 1% difference, someone could argue it does matter. Someone could argue it doesn't. But what if I told you being on the Discord, which I'd really love to look at some... Oh, they do have an undo button. And so I found the undo button. If I told you being on the Discord had a difference of 10 points on your grade, would that be practically significant to you? If I said students who are on the Discord have an average that is 10 points higher. And so actually, we could write out the null hypothesis for this. The null hypothesis would be that the true mean grade of students on Discord, which would be group 1, minus the true mean grades of students non-Discord is equal to 0. There is no difference. And the alternative would be that there is a difference. And the difference we observe is 10. So we assume null. Is that an offer? It's an offer you can't refuse. So if we saw a difference of 10 and it was statistically significant, that would probably be practically significant. This is kind of just an extended talk on what practical significance is, which is probably one of the most important things we should ever be teaching you. It's the literal, do I care? If I tell you there's a difference of like 0.02 between the grades of students on Discord, not on Discord, you're like, well, why would I join the Discord? Why would I care? It's not helping students. But if I tell you the difference, like via testing, not just tell you, but give you the data to back it, if the data shows that the difference between students on Discord and not on Discord is a difference of 10, well, then that would be very practically significant to most students. Now, does that prove Discord increases grades? No, but it would be evidence to suggest that they're associated. And we can't say being on Discord will increase someone's grade. It's just that students who are on Discord, we see this 10% difference. Not that what's occurring. Let's head back to the main screen here. It's open floor for questions again. Open floor. We can work more of the homework assignment. Let's try to do at least 2 or 3 more right here. At least 2. We can get 2 more done. I might pick a question if one isn't in the chat. Airline question, of course, Logan. Logan, 100 points. Thank you, Logan. And remember, you can ask questions at any time. We just kind of line them up. So if you're like, hey, Brian, can you do this question on the quiz? You got it. You're welcome, Mary Beth. Keep up the great work. Another 100 points from Mary Beth right here. The beach and... well, have fun. Enjoy. Sherry, enjoy. That sounds awesome. That is, if you are of age, have fun responsibly. Sound like an old person. When do you at what age are you old? Oh God. At what age? Who wants to put that in the chat? What age are you old? We're just trying to scare everybody here. We're getting the quiz loaded up. Random poll of the audience. At what age are you old? At what age are you old? I don't know. I'm 24, so I turned 25 in a week. Not true. I forget sometimes. I'm like, wait, how old am I? 60? Logan, I like that right there. 60. My parents are old. I got cousins who are almost old. Oh gosh. How old my oldest cousins are like in their mid 50s. Holy mackerel. So I got some older aunts and uncles. Airline question, where are you at? Is it chapter 15? Destiny, I think people said it's November 3rd in the morning. November 3rd in the morning. Which one is where's the airline question? November 4th. Kayla, thank you so much. I'm trying to find the airline question. Is it like returning luggage or something? Found it. Thank you, Logan. We got this right here. Logan, 100 points. Thank you, everyone, for asking. Let's hop in here. Let's do this. All right, here we go. Sad music. We have an airline right here, which claims 91% of people get reunited with their luggage within 24 hours after the luggage is lost. A consumer group who surveyed a large number of air travelers found that only 83 of the 196 people who lost the luggage on the airline were reunited with the missing items by the next day. Does this cast doubt? This one tricks me. So what do we need to do first? We need to do some notation. So what is the 83 out of the 193? Who knows what the 83 out of the 193 are? Got 83 out of 193. So what are the 83 out of 193? And they're claiming 91%. That is P naught. P naught right there is 91%. And Q naught is the complement. It's 0.09. Great job. It's X. X is 83. X is equal to 83. And N is equal to 196. P naught. The hypothesized. And you can tell it's P naught because it's over here in the hypothesized proportion. That's where we write the P equals P naught, which is the null hypothesis. Now, I'm assuming we meet the assumptions here that this is a randomly selected group. It was less than 10% of all airline passengers, and we have at least 10 successes, at least 10 failures, according to NP naught. We could check that. NP naught would be found by doing the following. N is 196, and P naught is 91. That's at least 10. And there's Q naught times this, and there's at least 10. So we have at least 10 successes, we have at least 10 failures. Random, 10% success failure because it is categorical. Because categorical, just remember, you got to check if it's categorical quantitative before doing the third condition. So the null hypothesis is the equal sign. That's the easy one. If we're trying to cast doubt on the airline's claim, I'm assuming, and we're trying to show that the true proportion is less than, because we're trying to see if it's not, like if they're not meeting a standard. Like they're saying we get back 91% of luggage to the customers, and we want to say, I think that it's less than this. I don't think you're meeting that. We're going to find out the hard way if we get it right or wrong. So now we need to find P hat. P hat is equal to X over N, and that's just how many successes we have in the sample. So that is equal to 83 divided by 196. And let's take a look right here. 83 divided by 196, and that's 42.34, 42.35. Ooh, not looking good, right? So that's 0.4235. Not good, not good, not good. Let's go ahead and solve our equation right here for P hat minus P naught over P naught Q naught over N square root. There's the equation for the z-score. And the z-score is going to equal to P hat, which is 0.4235 minus 0.91 over 0.91 times 0.09 over and 196. That was the sample size. And so let's solve this right here. So to solve this, we plug it into the calculator. 0.91 times 0.09 divided by 1.96 square root 0.4235 minus 0.91. And the z-score is negative 23.8. So they are way below their claim. That's what this means. Like in context, that means they are way below the claim. Here's what the p-value looks like. Here's our normal curve. Here's where we landed. And that's the p-value. This is ridiculous. Can you tell me an estimate of the p-value over here? Who in the chat for 100 points has an estimate of what the p-value would be for this? Like the p-value is going to be the area below this. We can confirm it with the David M. Lane. Here's your normal curve. I had to zoom out. So what do you think the p-value would be? And what does the p-value tell us? That with what we observed right here, we observed something this far away from the center of the curve. And the center of the curve is where the null is at. The null hypothesis is at the center of the curve. And here's our observed results. So this is the z-score, which is a standardized way of looking at the p-hat. So we're basically viewing p-hat standardized down there. And then the p-value is the highlighted portion on the curve. So this is the p-value. And so what is it? I like that right there. Kayla, 100 points. You're on the right track for this. Exactly. Let's go ahead and solve this and show this. So the z-score was negative 23.8. I believe that was right? Negative 23.8. Oh, we lost it. Let's double check our work. Negative 23.8. And let's show it again. Negative 23.8 right there. And so the p-value, Kayla's estimating it to be 0. And then if the p-value is 0, we're basically saying that this is impossible given the null is true. Do the survey results cast doubt on the airline's claim? Yes, since the null hypothesis is rejected, and we got that 100. So Kayla, you just solved the p-value without using the applet. We will use the applet. We can use the applet. Let's pull up the applet right here because the z-score, we go below because we did a less than test, negative 23.8. Remember, it's so far off the curve, you don't even see it. So Kayla, you just figured out without the applet. You're like, well, this z-score is ridiculous. This z-score is so far away from the curve that the probability of this occurring is basically impossible. And think about that. If the airline is saying 91% of their customers get their luggage back on time, and then you see in a sample that only 42% of customers are getting their luggage back on time, what you're observing in the sample is virtually impossible given the null is true. If the null is true, you should see something close to 91. You observed something so far away that you're like, nah, I'm rejecting your null hypothesis. That null hypothesis can't be, not that it can't be true, but it's virtually impossible for it to be true to observe 42% of the customers getting their luggage back on time when 91% is the truth. That would basically never happen by random chance, like as close to never as you can get. Given 91% is the truth, we should not see results like this. This p-value right here is virtually 0, telling us that this is virtually impossible. I reject your null because my results are virtually impossible given what you told me is true. So I don't think this is true. Put a big X over this and say, nope, oops. We'd say no to this right here. This is rejected. We have evidence that the true proportion is way, way less than it. Oh, awesome. Awesome, Forrest. Forrest, 100 points. Thank you for swinging by, Forrest. Good to see you here. Awesome work. Have fun in class. I don't know if you're online or in person, but so good to see you here, Forrest, and hope you're having a great day. Let's go back. We got time for another question. Let's see here. The next question is, I love when people swing by, just to swing by and say, hey. Let's go to intense music. Next question is scary, intense music. It's too scary for me. More chill music. There was another one I saw. The next question is... I think Logan asked this one. Airline question on the quiz. People asking my Canvas content. Oh, is there not another question? Let me see, find one we haven't done here today. Drop your question in the chat. We didn't do this one yet today, haven't we? No, we did the vitals. We did the organization monitors. I like this one. Let's go do this one real quick. Here we go. Nulls and alternatives. Let's check it out on Stat 201. So we have right here in the 1950s, only about 40% of people graduate from high school. Has this percent changed? So when we're doing this, we need to see what the alternative is. The alternative is always the evidence-based claim. So they're asking, has this changed? So changed is going to be the alternative does not equals to. Don't know how I keep changing things right here. Speaking of change. And so we need to go here and put the does not equal sign for the alternative. A lot of choices, but the alternative is going to be the evidence-based claim. And the easiest thing to know, he's got to repeat this. The null has the equal sign. When we write out the null in statistical notation, it always has the equal sign. So we can just knock out all those right there. Now, what they're asking you for here on the first part is going to be the notation for what we're testing. Are we testing the true mean or the true proportion? These other answers will never be used. We're not testing the sample mean or the sample proportion. We're making statements about the true mean or the true proportion. It's worth noting, and we covered this in class today, when writing out our nulls and alternatives, there's 3 ways we can write them out. I've got them on the screen. You have here what you're testing. You always write the equal sign, and then you write out the value you're testing against. So one way of doing it is to do the true proportion is equal to some hypothesized true proportion, the true mean is equal to some hypothesized true mean, or the true difference between two means is equal to 0. You can test other values, but we usually just test to see if it's equal to 0. So they're testing you on that first part right here, and so the question becomes, is it mu or p? And to know if it's mu or p, we have to ask, is this a categorical question or quantitative? We've got only 40% of high school graduates went to college, so that's did you graduate high school, which is answered yes or no, and that's proportions. 20%, yeah, Mackenzie, yeah, let's do it next. We'll do a version of that, you bet, Mackenzie. 20% of cars of a certain model have needed costly transmission. So does your car need transmission? The manufacturer hopes with the redesign of a transmission component has solved the problem. So this is categorical also, so it's proportions. Does your car need transmission help? So the P goes here also. Whatever goes here also. And they want to fix this problem, so they want to see that they've decreased. The true proportion of cars that need the transmission replacement is less than 20%. Try to read as a sentence. We field test a new soft drink flavor, planning to market it if only sure that over 60%, that's the claim they're looking for. They want to see that more than 60% of people like it. And the question of do you like the soft drink is proportional. You give someone the soft drink, you say, do you like it? And that would be a proportions question right there, the proportion of people who like the soft drink. And we've done it. Let's go do some Canvas content and office hours. Good practice. Practice writing those nulls, practice writing those alternatives. Let's do some Canvas content and office hours here. Canvas content coming right up. Let's go check it out. When's the Canvas? I think it's due tonight, isn't it? Canvas content. Oh, is number 9? Oh, I think you asked for number 9, right? New one. Yeah, Mackenzie, Canvas content number 9, hypothesis test. Like it. New one. I thought we were doing the old one, but no, we're doing the new one. I almost went to the old one, Mackenzie. So let's take a look right here. I get so many weird, random emails. Man, I miss the days of not getting crazy spam. We didn't do the whole thing. We did a good portion of it. We didn't do the hypothesis testing on the mean, which we'll do next time. This week is all about hypothesis testing, all about testing hypotheses. So let's hop here to chapter 15 and chapter 16. We should be able to get through. Chapter 16 will probably be finishing on Monday. I might move this to Tuesday or something. Let me do that now while I do it before classes. Might move this to Tuesday. Let's go check it out. Here we go. Canvas content number 9, one of the last ones. Let's go do it. A new diet is being tested. The inventor claims people lose 10 pounds on average in 6 weeks. 25 people are randomly picked to try the diet. Researchers are concerned the inventor's claim is exaggerated. The sample yields an average of 0.9 and a standard deviation of 6.5. Calculate the appropriate test statistic. So this one is a huge notation test. Like, you talk about notation. We've got right here 25 people are randomly selected. So with the 25 people randomly selected, that is your sample size. We see a sample mean loss of y bar. That's the mean. And the standard deviation from the sample is this. And I think that's it. And they claim 10 pounds. The inventor claims people lose 10 pounds. 25 people try it, and they lose 9 pounds. Oh, wow. Okay. So this right here is mu naught. This is a thing we'll cover more next time. But mu naught right here is going to be used in the equation y bar minus mu naught over S over square root of n. And this will solve out to a t statistic right here. And let's go ahead and solve this. And the t statistic is what we are looking for. This is the test statistic right here. So that is the test statistic we are solving for. And so let's take y bar, which is 0.9 minus mu naught. That right there. And we are below what we expected. S is 6.5. That's going to be divided by square root of 25. And the t statistic for this is going to equal to, let's solve it. Square root of 25 is 5. So 6.5 divided by 5 is, my brain's breaking, 1.3. There we go, 1.3. And 0.9 minus 10 divided by that. And we get -7. That's a rather far away t statistic, even for the small sample size. This same sort of thing, we'd plot it on the t curve. We'll talk about this more on Thursday's class. But this is the t statistic being calculated to test a one sample t. The only thing we didn't do notation wise, it's a one sample t. So the degrees of freedom for this problem are going to be n minus 1. And so with n minus 1 degrees of freedom, this would be degrees of freedom equal to 24. And we'd have to go to the t-curve and plot this. But I can tell you right now, the p-value is going to be 0. Just to finish off this problem, as though it were a full complete problem here, I'm going to go to the t-curve and just show you what you would do. We already have everything written out except for the null hypothesis. So really, this is just a full problem now. The null hypothesis. Oh, come on. Got to make it perfect. There we go. The null hypothesis, they're claiming people lose 10 pounds. So they would say, turn the ringer off. They would say the null hypothesis is that the true mean weight loss is 10 pounds. We're looking for evidence that they're wrong, that it's not 10 pounds. And then we go to our t-curve to show this. So we have a t of -7. And Mubot's got the t-applet in the chat. With the t-curve, we put in 24 degrees of freedom. We put in outside of it. So we want to go to the two tails and put in -7, and the p-value is 0. So we're so far away that this is basically, great job, Kayla, right there. And so this is basically impossible again, because once again, t's and z's are very similar. And so with this t-value right here, we'd say that the results we observed were virtually impossible by random chance. And so the t is what it wanted this whole time. What would it be less than? You could do less than. So you could try to show evidence that people are not meeting this goal. Yeah, I actually, you know what, Kayla, 500 points. I think Kayla is actually making a better point that if they're losing more than this amount of weight, as long as they're happy with the weight loss, that would actually be good for them. So we should look for evidence that the true mean weight loss is less than this, because if they have more than it, then they'd be meeting it. And what we saw in our sample was way less than what they claim is true. So we have evidence to reject the null, and the p-value is going to remain identical. It'll be half of what it was, but it's basically half of nothing. I don't know if we still have it up. It'd be half of nothing. So we just go here and go a left tail test, and it's half of nothing. So we get a result that is basically impossible at random chance, and we would reject the null hypothesis. So we just did basically a full problem for next class right there. So good stuff. A new diet is being tested. Oh, I think we have the same thing. So now this one's easier because we got the same sort of problem. The null always has the what sign here, Kayla. Just drop one thing in the chat. The null has this. It narrows it down to 2 choices. And the investigator claims people lose 10 pounds. Researchers are concerned if this claim is exaggerated. Okay, they're going. That's awesome. Well, it's not awesome, but yeah. Has the equal sign, and if they think the claims are exaggerated, they're going to look for evidence it's less than that. Don't fail me now. Don't tell me I'm wrong on that, which is what you were saying. When you reject the null and the null is true, what error have we made? The answer is type 1. So this is the way to memorize this. In a type 1, what letter am I making for you right here? In a type 1, the null is what? In a type 1, the null is what? So what letter am I making for you right here? So this is the way to memorize this. In a type 1, good to see you, Ivy. In a type 1, the null is this. Not today, my campus. In a type 1 error, the null is this. What letter am I making for you right here? What letter is this? What I'm making right here with my fingers. Type 1, the null is true. And if the null is true, it would be an error to reject it. In a type 2, here's 2, the null is false, and we fail to reject it. So in a type 1, the null is true, and we reject it. In a type 2, the null is false, and you do the second one here, you fail to reject it. So a lot of this, I've had people tell me, wait, that's so much easier to remember than they put these grids in textbooks, which are virtually impossible. You're like, well, you just got to memorize the grid. So in a type 1, the null is true, and we reject it. This is an error. In a type 2, the null is false, and we fail to reject it. So there's the 2 F's of a type 2. When we reject the null and it's true, 100% type 1, type 3, and 4 don't exist. They don't exist. A type 2 error is made. Kayla, A, B, C, or D. I want you to practice right here. Great test question. Practice with what we just did with the type 1, type 2 stuff. Tell me A, B, C, or D. Like, this is a test question. Don't worry if you get it wrong. But use the tricks for these right here and tell me, do you think it's A, B, C, or D? I think we got it. I didn't even know this would be the next question. False and failed. Exactly. The two F's of a type 2. When type 2, the null is false and we fail to reject it. And we always talk about the null. It has nothing to do with the alternative. So Caleb was able to identify. Great job, Caleb, right there. Type 2 is when the null is false and we fail to reject it. Literally exactly what I was saying, how the type 2 has the two F's right there. And we get that question. That's awesome. A smaller p-value would provide stronger evidence against the null hypothesis. Not to give away the answer. No answer text provided. Awesome. Yeah, the lower the p-value. Think about that airline question we had where we were like, oh, this is a lot of evidence. When the p-value is a lot smaller, there's even more evidence. Let's do one more version of this. Don't tell me I got anything wrong. Don't you dare. Don't you dare. 10 out of 10. That's what I like. Let's do one more version of this right here. A good one right here. This is the same diet one we had earlier. They're looking, the null has the equal sign. Good thing to always know. And then we have that they're trying to find evidence that the claim is exaggerated, that they're not meeting it. A new diet is being tested. This one changes it. I'm going to run the calculation. Please check out the one we did previously. I'm going to run the calculations here quickly on this just to solve it. But if you're wondering how I'm getting this solved, please check out earlier where I solved this. They claim 6 weeks right here. They lose 8.2. That should be right. Enter 2 decimals, 1.62. If you notice, this time they were above the claim. So it has to be a positive z-score because this time what we observed is greater than the claim. Should be right. Lower p-values are evidence of a cause and effect relationship, true or false? You got this right here. This one, if this is on the test, is like, come on. You can't get me on that. Lower p-values are evidence of a cause and effect. Now, low p-values are evidence against the null, but the bad words right here, this is false. We never talk about cause and effect. You can't say something causes something else in statistics unless you're doing experiments and stuff like that. But this mentioned nothing of an experiment. So unless you got those things in place. When we reject the null and the null is true, we have made a what? Review? Type 1 error. In a type 1, the null is true and we reject it. A type 2 error is when the null is false and we failed to reject it. Yeah, it's like, no. It's like, yeah, like I accept this is true. No. I think I got it. I'm worried about that one I did really quickly. What? Oh, no. How'd I solve the math wrong? Let me check my mathematics. Work something too quickly. Standard deviation is 6.8. Sample size of 25. 1.36. Take the observed mean of 8.2. Oh, did I minus... Wait, whoa. What's going on right here? It's 10 pounds. I did the 6 weeks. It's still 10 pounds. Oh my gosh. That notation. I was using mu naught of this. So observed of 8.2 minus mean. Ooh, is what happens when you run a problem too quickly. Even I can make mistakes if you do a problem too quickly. I was just doing that to make sure you mark your notation. I don't think we have it up still from previously. But check out the first version of this where we marked our notation and we didn't make the error. If you were watching closely, Brian made an error, which sometimes we make. Sometimes. Today was the day, my person. Or canvas, my canvas. Or canvas, my canvas. This is mu naught. And so that is the hypothesized value. This right here, Rock.
It doesn't matter.
That's not something that matters to this problem. It caught me. It tricked me. I thought it changed what mu naught was to 6, so I tested 6. Should have tested 10. But do your mathematics. Be very careful. Double check your work and put the right numbers in. If you do it too quickly, you could make an error. Repeat problem. We did it too quickly. I was just seeing if you're paying attention. Not today, my canvas. With that, everybody, 100 points in the chat. We're going to head off here. Don't let those questions catch you. Write down your notation. Puppet Shark, you so rarely appear. But we miss you. I'll be teaching here in 19 minutes. Bye for now, everyone. Bye. You got it. Write down your notation.